Okay, sorry I am not there, but this would have been your warm-up today. So go ahead and pause the video right now and try to do problems 1 and 2 on your own. And then I'm going to go through them. Hopefully you've already paused it and tried it on your own. So n is our counting term, the term number. And our sequence a sub n gives you the term value after you plug n in. So if they want you to find the first 5 terms, that means you're going to do n equals 1, n equals 2, 3, 4, and 5. You don't have to show this on test day. And then you're just going to plug n in. So in this case, n is going in the exponent. A negative number raised to an odd number always comes out negative. And a negative number raised to an even power comes out even. Comes out positive. Because if you have an even number of negative signs, they cancel out and you get a positive. So negative 1/2 to the first power is just negative 1/2. Negative 1/2 squared, I just said even exponents make it positive. And then you just square the top and square the bottom. 1 squared, 2 squared. Cubed is going to be negative. Cube the top, cube the bottom. Fourth is going to be positive. 1 to the 4th, 2 to the 4th. 5 odd is going to be negative. 1 to the 5th, 2 to the 5th. So the part in red is the answer. That's what we're looking for. By the way, test scores are online, obviously. Your tests were really good, and this sequences and series chapter won't be an essential skill because this is our last chapter of the semester, so there won't be time to test you on it twice. So this is going to be points on the test, and like a lot of points, right? It's a whole chapter. But conics will be tested for your second time, and that'll be the only essential skill on this test. So moving on. N equals 1. This time there's 2 places to plug the n in. I'm just going to do it in my head. 1 plus 1 is 2 over 1. The over 1 is optional. 2 plus 1 is 3 over 2. So it's always 1 higher on the top, right? Higher than n, 4 over n itself. 1 higher, 5 over n itself. 1 higher, 6 over n itself. And these sequences aren't any special type of sequences. We're going to learn 2 special ones this year, but these are just random sequences that we can create. And number 2, write an expression for the nth term. So you always want to check and see if maybe it's adding the same number every time, or subtracting the same number, or multiplying the same number, or dividing the same number. I can't multiply. Well, I mean, I can multiply by 13/7, but I don't think that's going to be the answer. So one way to go from 7 to 13 is to add 6. But then it has to work every time, right? Plus 6 is 19. Plus 6 is 25. So they're definitely adding 6 every time. If you're adding the same number every time, a sub n for sequence notation, that's like saying our slope is 6. So 6n. And then because our counting term starts at n equals 1, that's when n equals 1, and that's when n equals 2, and that's when n equals 3, you can figure it out, right? Like, if I know it's 6n because that's my slope, that's the change from one term to the other, what would have to go here so that my first answer is 7? This would have to be a plus 1 in red, sorry. But another way we could think about it is if you take it a step backwards, if you minus 6 to the n equals 0 term, because that would be your y-intercept. If I minus 6, that's going to give me a 1 in that spot, which is why it's 6n plus 1. Also, you can check, I don't know, plug in 3. 6 times 3 is 18, plus 1 is 19, so it is working. You can always check it before you turn it in. B, again, I could times by 7/4, but that's kind of weird, and that's not going to work every time. They added 3, but then they added 5, so it's not the same number every time. So sometimes you just kind of have to look at it, and if it's not the same, adding or subtracting or multiplying by the same thing every time, sometimes you want to look at the ends. So just start labeling things, n equals 1, n equals 2, n equals 3. And then see if you can figure out, what can I do to this number to get that number? What can I do to this number to get that number, etc. And if it's not adding, subtracting, multiplying, dividing by the same thing, sometimes try exponents. So I had given you a chance. Remember, I told you to try these on your own. You can pause the video at any time. If I do n squared and then add 3, 4 squared is 16 plus 3 is 19. 3 squared is 9 plus 3 is 12. So hopefully you can see that it works. So that's one of those sequences that doesn't have like a fancy term or anything like that, fancy name. It's just one that we have to be able to kind of find the pattern and figure out. Okay, pause the video on these two problems and try these on your own. So number 3 is written recursively, and I need you to know that our book might write it like this. Still A1 as 15. So what this is saying is your next term is your most recent term plus 3. So the book might say your next term this way, k plus 1. So in that case, your most recent term was 1 less than that, so just k plus 3. So your most recent term plus 3, or your most recent term plus 3, depending on how the book writes it. So that means they give you A1. We just want the first 5 terms. So 15, comma. And then it says, take that number you just wrote down and add 3. 18. Take that new number you just wrote down and add 3. 21. Take that new number and add 3. Add 3. These are the first 5 terms from that recursive sequence. Okay, now if you watch the video over break, and if you actually have the sound on, I told you that this is not 5, right? This is 5 factorial. And it means 5 times 4 times 3 times 2 times 1. And we all know that times 1 is not necessary, but it is the definition, so we will continue to use that. So if we are simplifying by hand, which you could probably expect to do on test day, we want to find the largest in the numerator or denominator, right? The largest term, and we want to expand it. So if my choices are n or n plus 2, something plus 2 is always going to be bigger than just the something. So I'm going to leave the n factorial, and I'm going to start expanding the n plus 2. So that's going to be itself times 1 less. Well, 1 less than plus 2 is plus 1. Times 1 less. Well, 1 less than just plus 1 is just going to be itself. Now, I could keep going and say times n minus 1, times n minus 2, but where would I end, right? I don't know what n equals. But luckily, is right here, we hit the top. So as soon as you hit the term on the top, just stop at the factorial part, because that means minus 1, minus 1, minus 1, minus 1. And those entire things will cross out. When a numerator crosses out, you still have a 1 up there. And there is no need to expand this unless the book makes you, but you still don't have to. But if you wanted to check your answer, you could. Or if it was multiple choice, you could expand it to make sure you got it right. So that's how you do it with variables. Same idea with numbers. Find the biggest number, 8 is the biggest. Leave the 5 factorial because that's second biggest. And I'm going to have to expand the 3. So 3 times 2 times 1. So I'm going to leave the second biggest on the denominator, and I'm going to expand the biggest number that I see, the 8, in the numerator. 8 times 7 times 6 times 5, 4, 3, 2, 1, but I could just write that as 5 factorial. These match, so I can cross those out. 2 times 3 is 6, so I can cross those out. And 8 times 7 is 56. Okay, last 2 problems, write them down, try them on your own. This big E looking symbol is Greek letter sigma. Just that symbol means sum it up. You're going to add these up. See how number 4 had directions and it said simplify, and number 5 has no directions? That's because this big sigma with all these numbers and stuff is the directions. All of this is telling you, sum up this sequence from 1 to 6, and your sequence is given right here. So that means, and you don't have to show all of this on the test, that means you're going to plug in 1, 2, 3, 4, 5, and 6. The index, those little numbers are called the index. The top tells you where to start. I should probably use I's. The bottom tells you where the end. Let me change them all to I's. But it means the same thing as n. And I wouldn't like care if you called it n. This is just my work anyways. But so from 1 to 6, plug in the numbers and see what you get. And then the sigma part tells you to add them together. So plug in 1, 2 minus 1 is 1. 4 minus 1 is 3. 6 minus 1 is 5. 8 minus 1 is 7. 10 minus 1 is 9. I'm just plugging this number into the equation. 12 minus 1 is 11. Add those up, and you get 36. Number 6. You're going to start at n equals 2. This time I should start with the I, like I said. I equals 2. 3, 4, 5. Notice from 2 to 5, there's 1, 2, 3, 4 numbers, right? People always think, oh, 5 minus 2, there's going to be 3 numbers. No, it's 1 more than you think. Now, this sequence is just 3. So if I equals 2, what's the sequence going to be? 3. If I equals 3, what's the sequence going to be? 3. No matter what, the answer is 3. 3 added up 4 times gives you 12. Okay, this would have been the warm-up you would have done with me if I was there. I hope it helped a little bit. I know I sound terrible and it wasn't the greatest, but it's all I have for you guys today. I hope you guys are doing good. Make sure you work on your book work and your Schoology quiz, and watch tonight's video as well.